Welcome to the Deep Dive. Today we're asking a pretty fundamental question, really. Where does oil and gas actually come from?
Yeah, it seems like a settled question, but our guide today, well, it's this book, The Deep Hot Biosphere, The Myth of Fossil Fuels by Thomas Gold.
Right. And Freeman Dyson in the foreword, he calls gold uh, always original, always important, usually controversial, and usually right, which is quite the intro.
It definitely sets the stage. And to help us unpack this, we're looking at the Amazon page, the description, reviews, what people who've actually read it are saying, both critics and readers.
So our mission really is to get under the skin of Gold's ideas. They're surprising, definitely controversial. Forget maybe what you think you know about hydrocarbons.
Exactly. We're talking about this idea of a huge biosphere deep underground and his really radical claim that most oil and gas, it's not from ancient life at all.
Which, yeah, that really flips the script. I mean,
Yeah.
for over a century, the standard story has been fossil fuels, right?
Yeah.
Compressed plants, dinosaurs, millions of years.
That's the textbook version. But Gold comes along and says, hold on. What if these hydrocarbons are actually, primordial, part of the Earth's basic building blocks from way back when it formed?
That's not just tweaking the theory. That's turning it upside down.
Completely, a fundamental rethink.
Okay, so let's start with Gold's first big proposition. This deep, hot biosphere. It's not just a minor thing, is it?
No, not at all. The scale he imagined is, well, staggering. He thought this subterranean world, full of microbes, adapted to incredible heat, incredible pressure.
Yeah.
It could actually be bigger in total mass, total volume, than everything living on the surface. All the plants, animals, everything we see.
Wow. Okay. So an unseen world, potentially bigger than the seen one. That messes with your assumptions about life on Earth, doesn't it?
It really does. Where life can exist, how much life there might be, it challenges all that.
And the things living down there. They'd have to be tough.
Oh, incredibly resilient. These aren't sunbathers. Gold pictured thermophiles, heat lovers. Bacteria thriving in conditions we'd find, well, impossible.
And what are they eating down there in the dark?
That's the connection. According to Gold's hypothesis, their main food source is hydrocarbons. Natural gas, petroleum, seeping up constantly from deep within the Earth.
Which leads us neatly to his most, let's say, provocative idea. The
Yeah.
one that really causes the stir.
Right. The really core controversial claim that most of Earth's hydrocarbons aren't biological leftovers. They're not from fossils.
So where do they come from then?
He argued for an abiotic origin, meaning these compounds were just part of the raw materials, the cosmic dust and gas that clumped together to form Earth billions of years ago.
So baked in from the start, a geological inheritance, not biological remains.
Precisely. And that's a massive departure from the standard model that absolutely links oil and gas to ancient life buried in sediments.
Okay, but these are big claims. Did he have any evidence, any support?
Yeah.
It couldn't just be a wild guess.
Well, it wasn't just him shouting into the void. You mentioned Freeman Dyson's foreword. Having a physicist of Dyson's caliber vouch for him, saying he was usually right, even while being controversial, that carries weight.
Sure. And it wasn't just Dyson, right? Other scientists saw something in it.
That's right. One of the reviews we looked at, from humaneventsonline.com, it mentioned scientists like Gene Whelan, Milan Kennicott, J.F. Kenny, people working in geochemistry, related fields.
Yep.
They apparently supported aspects of Gold's theories. So it wasn't entirely out there. It resonated with some specialists looking at the data.
And I found this interesting. The same review mentioned the U.S. Geological Survey, actually put some funding into research related to the abiotic theory.
Yeah, that's significant. It suggests that even within the mainstream institutions, there was at least some curiosity, some openness to exploring alternatives, not just dismissing it out of hand.
Which is how science should work, I guess. Questioning things.
Ideally, yes.
Then there's that specific experiment, the one mentioned in a customer review from Japan. The drilling in Sweden, in the Siljan Ring crater. Why drill in granite?
Ah, the Siljan Ring. That's key because, conventional theory says oil and gas form in sedimentary rocks, old seabeds, swamps, that kind of thing. Granite is igneous rock, cooled magma, not where you'd expect fossils or fossil fuels.
Right.
So Gold persuaded them to drill deep into this granite structure, and down at, 6,000 meters, they found natural gas.
In granite.
In granite. And also this magnetite paste with traces of microbial life. Now, it wasn't enough to be commercially viable, not an oil gusher,
Okay.
but it was evidence. Hydrocarbons in a place the standard theory said they shouldn't be, alongside signs of life deep down. It certainly seemed to support his core ideas. Does finding gas there prove the whole theory? maybe not. But it definitely raises questions.
So, okay, let's assume for a minute Gold's onto something. What are the big picture implications? What changes if he's right?
Well, first off, the whole concept of fossil fuels gets shaky. If they're not primarily from fossils, and if they're potentially upwelling from deep inside the Earth.
Then the idea that they're strictly finite, running out soon,
Uh-huh.
that changes too.
Potentially, yes. The book description talks about enormous stores of hydrocarbons upwelling. It hints at the possibility of, well, much more abundant, maybe even continuously replenishing supplies. Think about what that does to energy policy, resource scarcity debates.
Huge implications there. But you mentioned it's not just energy. It touches on the origin of life itself.
This is where it gets really mind-bending. Could life have actually started deep inside the Earth, in that stable, energy-rich, deep hot biosphere?
Instead of Darwin's warm little pond on the surface.
Exactly. One reader pointed out Gold has a whole chapter, chapter 9, dedicated to this. The idea is maybe the deep Earth, with primordial hydrocarbons for energy and heat from the planet's core, was a more likely place for the first cells to form, protected from the harsh surface conditions of early Earth. Maybe surface life can date her.
Wow. Okay, that's a big thought. Life starting underground.
And if it happened here?
Then maybe it could happen elsewhere. On planets that look dead on the surface.
That's the connection to astrobiology. Mars, for instance, what's barren up top. But if Gold's right about Earth, could there be a deep biosphere on Mars, fueled by similar geological processes? It certainly widens the search parameters for extraterrestrial life. Don't just look at the surface.
Some readers definitely picked up on the more immediate implications too, right? Energy policy, shortages.
Oh yeah. People reading this were clearly thinking about present-day issues. One review literally talks about the deception we have all been under about the so-called oil shortage.
Strong words.
Very. And another mentioned anecdotal reports from Russia about gas fields seemingly refilling after being depleted. Now, that's anecdotal, but if hydrocarbons are continuously generated deep down,
Then the whole peak oil narrative, the idea of running out completely, gets a serious challenge. Management strategies would have to change fundamentally.
absolutely, it reframes the entire discussion.
But let's be fair. The book itself calls these truly controversial and astonishing theories. It wasn't smooth sailing for Gold, was it?
Definitely not. As that New Scientist review put it, the book is contentious and passionate. Gold was challenging decades of established thinking. That always sparks debate, resistance.
And he wasn't afraid of that controversy, apparently.
Seems not. And another review, a German one, mentioned he initially struggled to even get his papers published in major journals. That's pretty typical when you're proposing something really disruptive. The system can be slow to accept radical new ideas.
It's always interesting to see what ordinary readers, people engaging directly with the book, take away from it all. What were their reactions like?
Generally, quite positive about the book itself, even if the ideas are challenging. People praised his logic, called him a first-class scientist by asking the questions. Others didn't. Said the book was well-written, made complex stuff understandable.
So accessible, even though it's dealing with deep science.
Right. And you got the sense many readers had these aha moments. Phrases like extremely fascinating, convincing alternative case came up, like it clicked with observations or intuitions they already had.
Interesting. Did anyone connect it to other big topics, like climate change?
A few did, yeah. Mentioning the hot biosphere concept and wondering how that fits or maybe challenges ideas about global warming. It wasn't the book's main focus, but you can see how changing one fundamental idea about Earth systems could make people rethink others.
And there was that comment about his background not being a traditional geologist.
Yeah, one reader made a great point. They said Gold had all the instincts of a good field geologist, even though his background was physics, astronomy. Maybe that outside perspective, free from geology's specific dogmas, allowed him to see things differently.
Right, a fresh set of eyes.
Could be.
Okay, so wrapping up this deep dive into Thomas Gould's work, what are the main takeaways we should leave listeners with?
Well, the core is this. Gold proposed a huge, hidden biosphere deep within the Earth, thriving on primordial hydrocarbons that are abiotic, not fossil fuels.
Which challenges our basic understanding of where oil and gas come from, suggesting they might be far more abundant, maybe even self-replenishing.
Exactly. And beyond energy, it offers a radical alternative for where life might have originated and broadens our horizons for finding life elsewhere in the universe.
These are definitely big, potentially revolutionary ideas. They really invite you to question some fundamental assumptions about Earth.
They absolutely do. And maybe the final thought for you, the listener, is this. If hydrocarbons are constantly generated deep within the Earth, what does that truly mean long term? For energy, for managing resources, for understanding life itself?
And perhaps what other scientific certainties might be due for a similar shakeup by someone thinking outside the box.
A provocative question to ponder.